Dear learners, welcome back to Engines and Transmission Systems, which belongs to Automobile Engineering. Today we will be seeing the Unit 2, that is Model 2, Ignition System and Combustion of Fuels. Once again, I am Dr. R. Venkatachalam, Professor, KSR College of Engineering. Once again, I welcome you all for this wonderful session. So, content of today's presentation is Ignition System, Ignition Coil Mechanism, Electronic ignition, combustion in SI and CA engines, air motion, knock, combustion chambers. So in ignition system, we can introduce this system to generate high voltage spark to ignite the air fuel mixture in SI engines. So trigger the spark is required. So that spark will initiate the fire. That fire will ignite the combustion. That combustion will produce the heat energy. That heat energy will be used to power the engine. So this ignition system functions to produce high voltage, then deliver spark at the correct time to ensure smooth engine operation. So timing must be maintained. Then if time maintained and properly sufficient spark is produced, that ensures the smooth function of the engine. This can be further classified to battery ignition system, magneto ignition system. Then electronic ignition system is sophisticated system which is most of the vehicles has nowadays. So ignition control mechanism need to be studied. The speed and load control. The purpose is control sparks timing according to the engine speed and load. So how much, whether it is a lean mixture or rich mixture, it should be properly burned or it should be ignited properly so that the required power will be obtained in the engine. So few methods are available for this: the centrifugal advanced mechanism, vacuum advanced mechanism, then electronic timing control. It has few advantages also: better fuel economy, higher engine performance, then reduced emissions is also aimed in this ignition control mechanism. So electronic ignition system consists of battery, ignition switch, ignition coil, electronic control unit, that is ECU, then sensor coil, then distributor, then armature, all these constructed. So the working principle of this electronic ignition system, that is EIS, to produce and control the spark required for combustion in a spark ignition engine, it replaces the conventional contact breaker with electronic sensors and a control module, resulting in more accurate ignition timing and improved engine performance. So you can refer the figure for this functioning. So components of this system: battery, ignition coil, electronic control unit, crankshaft position sensor, then ignition module and spark plug. So combustion in SI engine can be drafted with the pressure and crank angle. So you can look from the TDC, top dead center. So the crank angle starts with 70 degree. So it starts for peak pressure built up. You can see at the top dead center the piston meets. Then you can segregate into three sections. One is ignition lag, then propagation of flame, then after burning. So you can see from this figure, this graph starts from zero or near zero pressure to increasing, or atmospheric pressure to increasing the pressure to about 27 bar. So that is the peak pressure while full combustion takes place. From this point C to D, the expansion will take place, the pressure will be dropped. So this is how the combustion in SI engine takes place. So four stages can be seen. One is ignition delay, another one is flame development, third one is flame propagation, then fourth one is after burning. So similarly the compression ignition engine CI engine will take place where it is diesel engine. The pressure will be higher. If you see, this pressure is atmospheric to around 85 bar. It moves. So it start with this pattern is similar to petrol engine, that is spark ignition engine. So this also can be classified into 4 stages. First one is ignition delay, second one is rapid combustion, and third one is controlled combustion, fourth one is after burning. So this start from it also 4 stages that was given in the bottom. So initial start of the ignition is here, and the start of combustion is here, and the peak pressure built up. All the fuels or air fuel mixture inside the cylinder will be burned, so maximum pressure will be there. After that the expansion will take place, so the pressure will be gradually reducing. So flame propagation and abnormal combustion. So flame propagation is once the spark plug sparks the ignition, the flame will be spread over the cylinder top side. So burning rates affects efficiently. So abnormal combustion. So it should not be a smooth combustion. If some unburned fuels is there, then it will produce knocking, as well as prior to ignition start, that is pre-ignition, then detonation. After, some unburned fuel will produce knock, so that is detonation. So affects power loss, engine overheating, then component damage. That will be the cause of abnormal combustion. The flame propagation must be very smooth and it should be normal. If abnormal combustion takes place, the power loss will occur, engine overheating will occur, then component damage will also occur. Then air motion in CI engine. So important of air motion types: swirl, squeeze, tumble, all these required. So benefits: better air fuel mixing, complete combustion, reduced smoke, and improved efficiency. So knock and combustion chambers. The causes knock formation is long ignition delay, poor fuel quality, incorrect injection timing will causes the knock. Combustion chambers. So we can classify the combustion chamber into 2 categories. One is direct injection DI, another one is indirect injection IDI. So comparison: DI for higher efficiency, IDI for smooth operation. So after seeing this, we can conclude like this: the ignition system provides the correct spark at the right time, ensures efficient combustion and smooth engine operation. The proper combustion SI and CI engine improves the engine performance, fuel economy, and reduces exhaust emissions. So air motion, combustion chamber design, and ignition timing play a vital role in achieving complete and efficient combustion. So modern electronic engine ignition systems and advanced combustion technologies enhance engine efficiency, reliability, and environmental performances. This is how we are concluding today. We will see the next topic in the next presentation. Thanks for your time. Thank you.